Okay, great. So we'd just love to hear a little bit more about in terms of reality capture point solutions and also reality capture plus analytics solutions that you all have tried out, and what's worked, what hasn't.
Okay, we have looked at, we've at least looked at probably most of them that are out there. And we may have done, proof of concepts of various ones. So like, we've tried Hollow Builder before it was owned by Faro. We've tried OpenSpace. Our current company standard is Struction Site. They each edge each other out here and there on what their capabilities and features are. To be honest with you, our VDC teams and kind of tech teams preferred more the OpenSpace and Hollow Builders, but our field teams preferred Struction Site, and that's primarily due to the user interface and that it is drawing based and not model based. We've looked at Construe, Qpix, BuildDots. What else? No, there's others out there. I'm blanking on. At least it's Avere. Yep, we've used them. Avere and BuildDots, they're more for us. They're more kind of one-off type of solutions. We don't typically need that level of monitoring, mainly from laser scanning. We do our own laser scanning. We've used Leica. We currently use Faro. And we do a fair amount of scanning, but it's not something that, it happens a few times a project, usually not where we're doing something critical that requires constant scanning and updating. We more use 360 photo reality capture to do our progress tracking. We have used Struction Site's Smart Track, which they've now.
Jason, you cut out there. We heard the Struction Site Smart Track, and then it cut off.
So now it's
Jason, sorry, we lost you for about the last 30 seconds. So where you cut off was, trying Struction Site Smart Track, and then it cut off.
How about now? Can you hear me now?
Yeah, you're good.
All right, switch to a different network. Network may have been unstable. So Struction Site Smart Track, we've used that, loved it. They don't support that anymore, so it's now a new product that's not quite as good, but it's what we have right now. Work detection.
What is it about it that is not as good? I'm curious.
Well, the Smart Track gave us real quantities, percent complete, and quantities of production monitoring. But it was limited in scope. It only did kind of metal framing, drywall, ceilings type of scope. Okay. But it was really good. The work detection tool more just kind of says, hey, there's been a change in a particular trade. There's been ductwork added, or there's been a change in ductwork in this room, or change in plumbing in this room, or whatever. Which is great. It tells us where they're working, but we're not really tracking progress. We don't know necessarily what they did in that room and how much more they have to do in that room, right? Just that they're working in that room. So that one's a little bit of a challenge still.
Okay.
I'm sure there's others out there that I'm not thinking of at the moment, but
No, that's super helpful to understand. And I also thought your comment about with Struction Site, the field teams versus, VDC teams and tech teams, have different preferences based on kind of the 2D versus 3D model. And that's a topic that we're actively chatting with customers and prospective customers about, like, how do they want to see it, right? And like, how do we make the workflow? Because like if field teams don't adopt, right, it's a road to nowhere. So really appreciate hearing your feedback there. I think this is a great opportunity for NK to kick off the demo, because now he understands the landscape for you, Jason. And we'd love to make this conversational and like have you ask questions and get your feedback along the way. Because at the end of the day, I want to hear from you if you think this is different. So NK, over to you.
Perfect. So let me go ahead and share my screen. Yeah, I hope my screen's visible, Jason. Okay, perfect. So yeah, this is us. We are called Construct10, and the idea behind the name is twofold, right? We started out as construct to the power of n. Like, how do we exponentially increase the productivity at a job site by efficient project monitoring? But the main reason behind the n was also n number of data sources, right? You have drones, 360 cameras, laser scanners, LiDAR, iPhone LiDARs as well. And each one has its own purpose, right? You may want to do, laser scans probably only to do your floor leveling, check the leveling and do it once or twice when the slab is poured. But the progress monitoring, the 360 camera is very, very efficient. For the civil work, it's the drones. And then you have multiple different revisions of your schedule and design. These keep constantly evolving as the project moves on. So how do we take all these end data sources together, tie them up so that we give a very, very clear picture in a seamless way of what is happening on the ground versus where the project is supposed to be? So that's us. And since we started, we have been working with some large projects of Henselfels, for example. There are 3 airports that we are deployed on and multiple other sites. I'll take you through some of these projects because they're quite diverse in nature as well. So I'll start with something small, and then I'll take you through a couple of different projects. The first project I'm taking you through, Jason, is of a school expansion project. So this is in Atlanta, with Winter Constructions, one of the GCs over there. So the entire platform, the first inputs that we take in for onboarding a project is your design and schedule. So design could be your 2D drawings. It starts with the 2D drawings, but we have the ability to consume your BIM as well. But 2D drawings are good to actually get started. Like you have, say, 3D design, 2D drawings are given, and the schedule from a Primavera P6 or a Microsoft project is given. Day 0, the project is ready for captures. So day 1, you are ready to start your captures on this project. So we make the basic hierarchy, set up the floors, all of that is done. And the way we divide it is design, and then you have reality over here. So design and reality that you see. Right now, because we are in the overall layout of the project, we are looking at the drone scans. And the orange dots over here represents the part taken by the drone to collect all the imagery. Now, drones are great because, on the outside, they're quickly and autonomously, you see the green path, right? That's the path taken by the drone autonomously. Collect all the imagery, any path you take it, we give some high-level recommendations. We collect it, and now you can view it from these thousands of images. But what we do next is we actually stitch all this imagery together to form a super accurate point cloud of the entire site. Now we incorporate control points, and you don't need to rely on a separate engine. This is all within Construct10 only. So it's end-to-end. First time you use the control points, from the subsequent time onwards, we do automatic feature matching. So your registration is taken care of. And this would always be in perfect sync with your design. Like this is the existing building and there's the new buildings that are coming up over here across the different timelines. Now this is good because, from here I can go to the map view if required, look at the basic excavation, backfilling, the foundation works done or the basic structural works done. All that drone does a great job of it. And we start our tracking over there. In fact, the point cloud that you just saw is the common denominator across all the different data sets that we actually capture. And I'm going to show you the first part of the demo. I'm going to show you all the different data sets that we can actually consume on our platform.
And I just
So I-
want to kind of highlight that point, Jason. The fact that we're using sensor fusion to bring in all of these data sets comprehensively, right? Because one of the challenges you have with some of the players that are 360 camera capture only, right, is that's relatively low resolution, right? And especially when you get to quality use cases, right? Like, defect detection and that type of thing, it can get challenging. And especially within project types that have tight tolerances and you need that accuracy. So yeah, does that make sense?
Yeah, 100%.
Cool.
Perfect. So
Although,
from here,
I will say though,
Yeah,
one of my, my dream, I guess,
please.
is that we will photogrammetry from 360 photo capture, whether it's drone or handheld 360 camera. Most commercial construction in, probably like this project we're looking at here, when you're talking about putting together basically a photogrammetry model or converting that into a point cloud for analytics, right? We're talking about being able to do that within a few inch tolerance, right? It's not like a laser scan where you're getting down into the millimeter level tolerances, but you're getting within a few inches tolerance. And for most construction, understanding if something's been installed or not installed, few inch tolerance is enough. And so I'm interested to see what you guys are doing with this, because there's a lot of the platforms that say, oh, well, if we're going to do progress tracking, we have to have laser scans. And it's unrealistic for me to go laser scanning continuously and constantly to monitor progress tracking, right? 360 photo capture is very quick and easy to do. Anybody can do it. Just give them the camera and tell them to go walk, right? And then being able to know within a reasonable tolerance that what's been done, what hasn't been done. To me, that should be doable, but haven't seen anybody really come through on it yet.
Okay, so
Well,
you're saying your dream is to be able to do that with 360 camera data.
Yes, and then of course be able to tie that to manpower, right? And then that's where you get the real, if you have the production and then you have the manpower, then you can really start to see how you're performing.
Totally. We were actually talking about that use case with a superintendent last week where he said, show me the trend charts, show me, here's, the production rates, or, here's our, for installing drywall. And then, this is where we should be. This is where we are. If I can show my trade partner that trend line and light the fire. And then not only that, but if they show up with a crew size of 4 to do, X square footage of drywall, but I know that they need a crew size of 8 so that we don't all end up in overtime. I want to be able to say that and tell them to get more folks on the job. So yeah, totally appreciate that point.
And loved your feedback on that point around 360. And I think what we are going to show you next will actually cover some of those points. So let's jump now from the aerial shot, which again, the basic photogrammetry is there. But 360, what we do is a bit different. So we combine SLAM and photogrammetry together, and I'll tell you why. So 360 cameras, this is the normal standard walk that you would have seen in a construction site, open space, all of that, where the camera on your hard hat or on a monopod stick, just walk around. You can actually select your starting position and walk. You have the entire site covered. But what we are doing here differently is, 360 cameras are great because they have a great viewing radius. So they have 360-degree field of view, but the resolution is quite bad, right? And that's why at best case, the photogrammetry results will be a few inches. But what we say is, you have a very powerful device sitting in everyone's pocket, which are built for taking photos. Why don't we use this and do multisensory fusion? So we take your iPhone right now, the camera. In fact, if you have an iPhone 12, 13, 14 Pro with LiDAR, we take the LiDAR data as well. And we do fusion of these two data sets together so that you get a 1-inch accurate model, a 1-inch accurate point cloud. In fact, half an inch is what we are, is our internal bar, but at max, it will be a 1-inch accurate model of the entire site. So 360-degree data covered together. And I'll do that capture and I'll show you how that works as well. But for us, everything, even a 360-degree image you're looking at right now, the background is a point cloud, which is measurable to a 1/2-inch accuracy. So that is what is actually enabling us to quantify the progress also as it happens. And so this is a standard 360-degree camera. I can actually go back in time, do all the standard stuff that you would have seen, like between 9 June and 28 July, about 2 months difference, the same location. And you would see at that point of time, only the retaining wall was done. Now the structural work is also complete. But this is one, right? Now let me start sharing. That's the reason why I joined via my phone, which is an iPhone 14 Pro. It has a LiDAR sensor also built in. So very quickly, I'll do a live scan of the room that I am in to demonstrate how the multisensory fusion actually works. But I'll just pause for a second if you have a question, Jason, or I can just go ahead.
No, yeah, I understand. I mean, it's kind of like what Matterport used to do back in the day, where it was we were using both low range LiDAR with photogrammetry.
Right. So it is fusion. And you don't need a LiDAR. I'm demonstrating the LiDAR one just to show one more data capture. If it's a normal iPhone, in fact, Android phones as well, we have the methodology to fuse SLAM and LiDAR. And I'll show you what I mean by that. Let me just quickly stop my video and I'll start sharing my screen. Yeah, my screen should be visible now. And this is the Constructon LiDAR app. This is just to demonstrate it. This would ideally run in the background. And I would have a 360-degree camera along with me. So what essentially happens is I just need to start the camera. Now, hit record and just walk. So I don't care about covering the entire area. I just do a normal walk and two things happen right off the edge. One, you see the blue line over there, right? I get a real-time path in 3D. And this would be a decently accurate path. It's not accurate to the centimeter or so, because this is only SLAM in play yet. And you get a point cloud, a dense point cloud of all the objects over here. Now you see there are some holes, right? The camera has not looked into it and there are some holes. These holes will be covered by the 360-degree camera's photogrammetry. And by photogrammetry and SLAM working together, we get a dense point cloud, which is accurate and which is very fast as well, compared to traditional photogrammetry, getting you that 1-inch accuracy where everything becomes measurable. So this works with normal phones, your iPhone 10, iPhone 9, as your previous ones as well. just do normal capture, your path gets captured and the phone's camera. So camera, sorry, the camera, the visual inertial odometry, and the 360 camera all are working together to provide you more dense, accurate point clouds. So you get the right balance of cost, accuracy, and speed. That was the cornerstone of our design principles, actually. So this, and obviously, because we are doing this, I'll quickly show you one more modality of capture. Along with this, we do laser scans as well. So again, point cloud is the common denominator. So if someone does, say, once a month or, regular laser scans, you get that opportunity as well. So this is a Leica scan done. What you're seeing is the left side is a 360-degree walkthrough, and the Leica scan, which in this case has been used as a ground truth. So you can navigate through the entire area and, look at the laser scans, and the points will build up. So even though this is a very heavy scan data, the platform takes care of it, and you do not require laser scans to do progress monitoring. That is the main thing. You require it to do minute level quality defections, basically. And we are talking about, I need something a centimeter level or sub-centimeter level. That is when you would actually require a laser scan. But generally doing high level progress or deviation analysis, only the 360-degree camera with your phone is enough. So this is the first part I wanted to show you. What I've covered till now is the different modalities of data capture that we can actually consume on the platform, right? From 360 cameras, drones, laser scanners, iPhone LiDAR, all of them, and how we are leveraging them. Now,
Jason, before we transition, any thoughts or comments from your side?
No, I mean, so far so good. Do you have to do the iPhone imagery every time you do the 360 capture, or just can that also be done kind of like on a monthly basis?
we recommend doing that. So for example, right, some of our customer tried out, I have this historic data with Struction site. Can I give you that? And can you still process it and keep it live on your platform? We can do that. But then you compromise on the scale of the photogrammetry, because when you don't have any initial measurements, you don't have the true scale. So it could be 10 meters, the ceiling to floor height, or it could be 30 meters. You don't know. You would need to manually align it. The iPhone allows that to not to happen. And you're not actually carrying your phone. You can just put it in your pocket or on a lanyard. Just walk. You don't need it to be looking at everything. It's just making the data better and more richer in that sense.
Okay.
And the upload, in fact, what we thought was, for selecting your starting position, you're using the iPhone, and the upload of data also happens through the iPhone. Like 360 camera data gets sent to the iPhone and the sync happens from there. So we said, why don't we leverage this data as well? This is additional data which can be hugely beneficial, and it is getting collected passively. So again, you don't need a LiDAR device though. It could work off a normal iPhone as well.
But you don't have to do a separate capture. You're just if you have a 360 camera, you use the camera, and through the app on your phone, you're getting that resolution.
Absolutely.
Exactly. So there is, so that we appreciate that there's that added step of like, okay, I'm about to do the walk. Here I've got my, monopod or helmet mounted 360 camera. And then I'm hitting start on the Constructin app on my iPhone that's sitting in my pocket or on a lanyard and running simultaneously. So yeah, it is one more step to run it simultaneously, but as NK mentioned, then we get a better output in terms of resolution of the data.
But the camera on the phone isn't having to see or capture imagery.
It is.
Camera on the phone is actually looking out. It is actually capturing the data as well simultaneously, but it doesn't need to be looking at everything. Like I said, right? Put it in the vest pocket so that the camera is exposed and just walk. You don't need to point it to specific objects.
Gotcha. Okay.
So the next section, what I wanted to take you through, Jason, is, once we have the captures of the data, right? What kind of insights are we able to generate out of them? And finally, I wanted to show you how the AI engine actually works as well, because everyone tells AI, right? And AI is a black box. But I wanted to, for all our early adopters, we are showing what AI is, where we are actually using it, what is the kind of segmentation classification what we are doing, and how we are able to quantify every element of progress that has happened. So let me take you through that part. I'll start with the reports. So for the same project that we had actually seen, this is the school project. And I'll take you through, in fact, a couple of different reports. So take this building as an example. This is one of the other projects. What you would be able to do is, slice and dice the data to say between any two dates, what were the elements that were installed? Like these are the few dates that you have and the categories of elements that were installed. And you can slice and dice this data accordingly. Like I want to see only the walls which were installed or the wall work which was completed on this particular date, like this date to the previous date. The system tells you exactly that. And you're able to filter it by level, for example, every level, what were the installations done? And you can do it for every element, right? Every category of element, walls, your plasters, your floors, your plumbing fixtures. So the way we fundamentally built our engine is not to only recognize certain set of elements, but every element that exists in your BIM, we want to actually track it. So if it exists in your design, we should be able to track it. Some elements, even though if they're not there in the design also, we want the system to be intelligent enough to adapt to it and learn it. So that's the core of how we built our engine. And it can come from visual reports like these to analytical reports for the same building. You could see reports like these, where it's actually giving you the quantification of work that you talked about. Like what was the planned quantity, actual quantity, what is the delta, what is the total quantity and remaining quantities to be installed. Right from numbers to this was a project in India, so square meters, the civil work. In fact, if I expand it, you will see the RCC works will be counted in cubic meters, square meters or square feet for the internal plaster work, masonry work again in cubic meter. So every element is actually quantified per its dimensionalities. Like if it's a piping to be installed, I probably only want to track the linear feet that is installed. But masonry work or plastering work, I probably need the square footage of work done. So your planned and actual quantities, planned is coming from the design, but the actual quantities is coming from the photogrammetric point clouds. So we do segmentation on the 2D images, extrapolate it on the 3D, and everything becomes measurable for us. So these are highly detailed reports, and this customer wanted about 18 pages of reports. So these reports are, once we have the data, we customize it and give it to our customers, both the first level dashboard and this one that you see. Because we understand every project is different, every KPIs are different. You would want to present the data or tell your story in a different way. So we say we give you that flexibility. We can present it in any format you have. Like if you have a Power BI report, we can even give you out an API giving you the actual quantity so that you can plug in, or we can build that up for you. So these are some of the reports. In fact, the same school project that we talked about, right? Let me show you very quickly. So you see the different dates over here. This is again element by element completion. And you would be able to see on this particular date, what were the elements that were installed. And you'll get the actual elements that were installed on that particular day too. Like if I hide this, like this is the current progress on a date by date basis. It started from the retaining wall. And now this is the current stage of it. And obviously this reports can be analytical as well, right? It depends on how you want to look at it. Like I want to see level by level what is installed. You get to see it. This is the complete scope of the project. And this is what is done currently to this point. So easy visual reports, as well as, your 2D reports, all these reports, these are custom made for you. But I know your next question would be, this is representation of the reports. How are we actually tracking it, right? That would be the question. How are we tracking element by element, like say ductwork? How are we telling how the ductwork is actually complete? For this, I wanted to actually show you how our AI engine actually works. But I'll just pause over here again, take a quick pause, Jason, and see if you have any questions to this point along the reporting.
So this is all good and all the tech people love this, but the challenge we have is with the field. They're used to looking at drawings, right? And so it can be a model view, but I need it to be where I can, obviously you can rotate that around, right? And look at it in kind of a plan orientation, right?
Yeah.
But I don't see that on top of a drawing. Like they want to see the line work of that. In this case, we're looking at structure, right? So they want to see the structural drawing on top of that. They want to see the columns and the beams and all that in the drawing and the line work, as well as it's being color coded as it's done, especially when it comes to the MEP trades, because if I can, yeah, I'm sure you could show a view that shows like, here's all the ductwork that's been installed. But if I also can't see in that view the ductwork that hasn't been installed or the ductwork that's missing, then they can't fully understand the picture, right? Even though I give them a number and say, hey, you're 56% done on this floor with ductwork, right? And here's a picture of the ductwork that's been installed. And then they want to know, well, what about room 305, right? Okay, well, where's room 305? And then you're trying to find that room on the model, whereas if you were looking at a drawing, it would be right there in front of you, right? And then there's some note on the drawing that they want to see because you have a question about whatever. So this is one of the big hurdles that we have had. There's a lot of solutions like yourself that have gone with this kind of model-based imagery or backbone, and it's great. But our field teams, they still want to relay that back to a drawing. They want to know where that grid line is and what room it's in, and those kind of things. Does that make sense?
Yeah.
In fact, that is a consistent feedback that we have also got. We started it over here, and that is what we are working on actively. Because, again, it's a very simple problem for us to actually represent this on a 2D drawing. And we are learning on, what is the best way they want to represent it, because we want to get it right when we get this. This was the lowest hanging fruit. We started with this, but we are talking to people like you to get that feedback and, understand and build it out exactly, which will make the most sense.
Yeah, and Jason, to that end, I mean, you make such a great point. And like I'm curious, like, are the field teams like marking up blue PDFs with Bluebeam, and are they using like SIPs to communicate? Like what's
Well, I mean, if you think about it, historically, that's what they do, right? And the old school way is print it out, laminate it, throw it on the wall, and take highlighter and color in what's been done and what hasn't been done. And maybe nowadays more of them do it all in Bluebeam, and they're doing their shading in Bluebeam, and they periodically print it out, right? Turn on, turn off, whatever layers. They want that same thing just in here, right?
Yeah.
And just be able to let the technology do the work, and they just click which dates they want to see. And on this date, this is what was done. And on this date, this is what was done. And here's your percent completes. And then I want to be able to print that out, that plan view with the color coding on it, and my percent completes and progress dates and things, and then be able to hand it to my subcontractor and say, this is what you've done so far. You need to be further, right? Or great job, you're ahead of the game, we're doing good. And then if I can tie that back to manpower and I say, well, hey, we're behind, it's because you've only had 4 guys showing up, you need to have 8, 10, 12, whatever it is. And then I have all this proof that shows me that, rather than relying on my superintendent to go ask a foreman, hey, how far done are you guys? And I mean, we've built these trackers in-house before. I've built them in spreadsheets and things where we took plan versus actual, and at the time we were using SmartTrack, and I had a foreman come and tell our superintendent, and my superintendent then try and tell area management that they were like 80% done on a floor with that particular trade. And then we looked at the data, and the data said they were only like 45% done. right? And the superintendents, yeah, they told me 80. I think they're about 60, 65, somewhere in there. We're like, no, you're only 45. And then here's the proof. You got a color coded drawing that shows you exactly what's been done and quantities to back it up.
Yeah.
And then they'll initially fight with you and they'll say, no, no, that's not right. We're more than that. And then you say, okay, well, do you agree with this drawing that shows all the color coding, what's been done? And they say, yes. Okay. When you apply math and science behind the quantities that's shown on this drawing and the color coding, this is how far you are. And then they shut up.
Right.
Right. But you have to take them through that process of explaining how it is that you're justifying and verifying what's there, and that you're not relying on the human element to tell you, or they can't sandbag you and say, yeah, we're 80% done, really only 40, but
Right.
But they really, for so many years, that's what they've looked at is the plans with
Yeah.
highlighter marker or blue beam on it. And so it's a great communication tool to communicate, this is where we are, right? And so I think that's where that's the direction that some of these technologies, such as yourself, with what you're doing. I don't think it's a huge ask, but it's just something from a user perspective that I think needs to happen to really make these things work well.
Great feedback.
Spot on, Jason. I mean, that is extremely helpful, and it is consistent as well, right, Meredith? We have heard this for the field to use a 2D drawings, and that will 100% be something we offer. In fact, our perspective or our hypothesis that we are testing out, Jason, is you don't even require a BIM to do progress monitoring. So any project which has a 2D drawing, you should be able to do progress monitoring right out of that, because the images and the drawings are aligned together. But we are testing it out. We have got initial results are great, but we want to further validate it.
Yeah. I know, I just want to do a time check. Do you have a hard stop in 12 minutes, Jason?
Let me check my calendar. I don't believe so, but let me double check. No, I am good.
Okay, I want to I just want to be mindful, because I think the next part that we're going to show, popping the hood on AI and not having it be a black box to our customers and prospective customers, is an exciting portion. So I just want to make sure we have enough time, but we'll certainly not try to go too far over. So back to you, NK.
Absolutely. So Jason, here we have actually put up an interface which actually shows the AI and work. And I'll show you a few examples of it, how this exactly works. So AI first, right? Every image for us goes through this pipeline. So you have an image from site over here that I've just taken. This is the same site, and taken a screenshot over there. But every image, be it a 360 image, a drone image, everything goes through this pipeline, and it's looking for elements out of the image itself. So first thing that happens is we need to segment and classify every element that is out there. And if your segmentation and classification are perfect, even for untrained elements, right, this works really, really well. So you would see the ducts over here, perfectly segmented out, perfectly labeled out. And there could be multiple classes that you actually given. So all the images, right, from drone images, 360 images, everything passes through this pipeline, where our system is actually predicting all the results, like this one. So you would want to remove a person from your 360, because if you're doing photogrammetry, the person will cover every image and it's a very bad artifact, right? So we mask out every person automatically through this pipeline. And you see, I want to get the floor measurements, the ceiling measurement, for example, out of this image, and then generally as well, and column. So I just take this, all these predefined classes are what we are tracking, and this could be constantly added as new classes as well. They could be something that the system has not been trained to recognize, and it will do a very good job of it, segmenting and classifying it perfectly. In fact, in this image, right, a person to the naked eye, if I were to look at it, I could at maximum say that 2 people. But the systems does a great job because it's looking at every pixel by pixel data. and it's actually identified 4 people on the job. So 1, 2, 3, 4, 4 instances. And that's where it becomes super powerful. Identify even small minute objects. Like for example, the floor is not only the floor, but it removes out that piece of wood or the piece of pipe that is there. It gives me out a perfect segment in that sense. Ceiling also is the same thing. It gives you out a perfect segment, and all this then go to our classification engine. So we have exposure interface like AI.construct and .ai is what we are calling it, where every project, right, will have this interface built in. The system will show you what are the new elements that have been added, what are the detections, what are the classes that we have actually recognized, and it will also correspond it with the element in the BIM. So I'll show you very quickly what I mean. Across the different timelines that you have, the system is giving me predictions. So it will give out all the possible classifications that exist. And in case I want to add a new object or retrain something that has not been detected right, I get the opportunity to do that. Just give me a second, I'll just refresh it. So this is still in beta, so it's only being used for internal users right now. But the idea is to expose it all to our external users as well. There are multiple versions. So they see what predictions have been made, is the AI engine working correctly or not, and do a comparison with your design and say mark up the elements. This can be in both 2D and 3D. Mark up the elements which have not been done. Like for example, over here, I would see the ceiling like this, the beams, all the beams would get highlighted, and say there's a new object that I want to mark. So this object is not there in the design as well, but I want to save this piece of equipment, this fan that is there. I can just say save and call it a equipment or put it any custom class. So that gets trained as a new object the next time when we go in. So every object is getting trained like this, and it's getting better every time it sees a new data set. And it could be small objects like these pipes, these wires. It would, one click would actually properly segment it. Or just to show one more example, like this pipe. If it was not pre-trained, I have an option like add one click, and the negative prompts, positive prompts, both of them. Just train it so that system identifies it perfectly well. So this is how we are forming that association, like columns, beams, all the important classes, including your pipes, including your equipment. Every new class, it's getting trained. And once you have sufficient data, right? And this is actually the sufficient data. What I mean is, I'll give you a very quick example. I don't know if you're aware of this company called Field AI, Jason. So the Boston Dynamics Spot?
Yeah, the field that does the safety.
They don't do safety, so they specialize in autonomous stack. How do I make data capture truly autonomous? And they say, let's take the Boston Dynamics Spot, attach multiple sensors to it, including the LiDAR puck from Velodyne, 360 camera. It will autonomously go every day, do the capture. You don't need people guarding it, as typically you would need for the Boston Dynamics Spot. So they put additional sensors on top of it. And now your data capture becomes autonomous and the analysis becomes autonomous. Like very, very quickly. So you see, this is the spot on the top. And these are all the elements that are detected. Even small elements like your outlets are the blue detections, the wooden frames. Every element gets segmented and classified like very, very perfectly, including your ducts, your pipes. This inferences, right, run, if I have the data in like 1 hour time, you would have all the inferences coming out. So very, very quickly we do that's why our turnaround time is 24 hours, and you don't need to do laser scans, right? Only 360-degree camera, use it. You get the photogrammetry, you get the results, everything becomes measurable, and then you are able to track everything as well. So, and we were able to work with this company because we were the only company who are multimodal, right? With the data sources, they had multiple different sensors put on them, but we were the only ones who could consume all the different data sets together and make sense out of them. So we give that flexibility, and then, your data capture can now be, say, daily twice, once in the morning, once in the evening. And by the time you are available on site next day, you have all the analytics, like where the work happened, did it happen as per the quality standards or not? It could make life so easy. But at the same time, we are not dependent on them. Like you can still do the regular 360 scans or the mobile scans and extract value out of this. So yeah, these were a few things we wanted to show, Jason. Thank you for patiently listening through all of this. We got your feedback loud and clear on the 2D drawings, and that is something which will be up very soon because, we have the core building blocks. Everything is only a representation in 2D. The only challenge we had over there was like, take pipes, for example, right? We were thinking, what is the best way to represent pipes? Should it be one continuous pipe we represent and then parts of it, or we label it parts by part, like how the BIM exists? So these are some technical challenges we were looking at, and we are talking to multiple users, right? So what is the best way to do it? But representation would be quite easy.
Okay. So you're saying 24-hour turnaround for the analytics. What
That is
about
correct.
for the actual photographs? Like, do they go any faster for just the photographic data? Like, can I
The
get that
photographic
in
data
a
should
short
come
turnaround? And
in a couple of hours, Jason. Typically, it's like if it's a large floor plate area, like 20,000 square feet, it would probably take around 4 hours time.
okay, but I can get the photogrammetry data before and then I have to wait for the analytics, right? Okay.
Exactly. Complete
Um,
reports.
and excuse me. Man, it's only Tuesday. My brain's fried.
I feel you.
What about things that aren't in the model? So like, so for example, small conduit a lot of times isn't modeled, right? But we want to get some kind of quantities of it, right? It's a little harder to track percent completes because you don't have a total quantity to work against, right? But at
Right.
least we can track that, hey, they are installing or making progress on small conduits. You mentioned, or you showed just a minute ago, the receptacles and the outlet boxes, right? Switch boxes, things like that. Sometimes those are in the model, sometimes they're not. But again, now that's something that I can easily do a quantity on. Like if I can manually enter hey, there on this floor, there's 300 outlet boxes or whatever. If I could manually enter that number, then at least I have a quantity that I'm working against. I don't know if you do anything like that.
We do. In fact, very good you mentioned that, because one of the use case with the field AI's customer, like the customer whose site it was, they had was, we have backings to be measured. I want to see if all the backings are put in the right place, and I want to track the quantity of backing installed, but we don't have it modeled, neither in
Right.
the drawing nor in the model, right? So we took that as a challenge, and we didn't even have it pre-trained, right? That was a new element for us altogether. So like within 24 hours, 48 hours, we got the model in place. So we at least got to a level that, we label all the backings that have been put in. We'll know where the backing is, what is the dimensions of those backings put in. At least that we can give you right off the bat. We will not be able to track the complete quantity unless you give a manual entry. Like you say, these many square feet of backing elements were supposed to be installed.
Right.
Then we'll give you the percentage complete as well. But that we were able to prove it out for an element which was not there either in the model or on the drawing itself.
Right. But theoretically, if I could do a 2D drawing, right, I could do a drawing that highlights all the walls that have backing in it, right? And then I could say, oh, very quickly, somebody on the team's gonna say, this wall doesn't have backing in it. Why doesn't it have backing in it? We missed that one, right?
Exactly.
Because there's a TV on the, whatever. yeah, so I'd like to be able to do things like that. Same thing for, we just had actually one of our office engineers did used Python to build a little model to track pile production. So
Right.
when you're drilling piers, right? Well, you can't see the piers in the photos necessarily. But I have a quantity and I know how many they drilled that day, right? So if I can put in the total quantity of piers and whether it's visible, it's usually visible in the photograph of where the piers are, so you can at least validate which ones have been drilled, right? Even though I can't see the pier, right? It's underground. Excuse me. So something like that as well would be a good thing to be able to do, is load things that I can't see. Here's how many piers they got to drill, and then every time they walk, hopefully it's picking up the piers. Or if I can make a manual adjustment to say, well, they we didn't capture video of this one over here, so some of those validation tools, weather data, also an integration with any kind of weather data would be helpful, because again, as we go further into monitoring progress, weather data is a factor, right? So if I see a dip in a production curve, is that dip due to a weather factor? And how much did that, if it was 2 days of rain, and how long did that really impact the job, right? Past the 2 days of it actually raining, how much did that affect my overall curve? And then do you guys have any tie-ins with Procore?
Yeah, there are two active integrations we are working on: Autodesk Construction Cloud, so that we can take in your designs directly, and Procore, where we can actually tie in all these RFIs observations for a bi-directional integration.
Whoops. NK, you cut out. Jason, do you hear NK?
I don't hear them.
Yeah, we lost your audio.
Yes, you don't need a separate login and everything as well. But
NK,
oh,
we lost like 30 seconds, so we just heard you say Autodesk Construction Cloud, also with Procore, bi-directional, then we lost you.
got it. So Procore, the idea is to become an integratable widget within their app. You don't need a separate login, so you get put it in the marketplace as well. And the basic partnership agreement is already done. We are working on integration, and it's scheduled to be complete by Q4 this year, Jason. So Procore is what we are doing, and I assume you are heavy Procore users.
Yes.
And then on that note, Jason, we would want to dig into how have you implemented Procore and what modules are you using? And is it observations for, quality detections, and how we would then tie in specifically for your workflow?
Yes, that, and then also with the BIM, you tie into their Procore BIM. I know you said about bringing in the Autodesk BIM, but do you bring the BIM in from Procore as well?
Right.
Save us a step there from having to, okay. And what about photogrammetry plan views?
Photogrammetry plan views as in, Jason, could you explain that?
So the easiest and simplest example would be a drone mapping, right? When you do a drone flight and you get like a satellite image of your job site, right?
Right.
Okay, well, that's great during that phase of construction, right? And then you top out the building, you close it all in, and now you're inside. Well, you're walking around with a camera that can see the floor, and it can also see the ceiling, just like what Matterport used to do. Was you could do a photogrammetry floor plan of your entire facility for each floor, and then you could also do a ceiling plan where you're looking up and seeing the actual photogrammetry ceiling plan. And then overlaying, getting that, first of all, getting the photogrammetry kind of orthomosaic view of a floor and your overhead, and then being able to overlay either the BIM or, again, ideally 2D drawings on top of that, so that I'm again validating what's installed, but also doing that in a way that I see the other things around it, right? Because if I just have a drawing of the ductwork and the VAV, right, the mechanical equipment, I don't see necessarily the conduit that's feeding it. I don't see the piping that's feeding it. But if I see that in the imagery, and then I see the ductwork in the drawing and the ductwork in the imagery, it's a great tool to have to be able to overlay those types of data sets. And if you have the photogrammetry, then why can't you take a slice of it, right? Whether it's in a elevational view or in a plan or reflected ceiling plan type of view.
No, I think this is a great idea, Jason. Till now we haven't even considered it, but we have the photogrammetry data, and there's a way we can slice both the ceiling, floor, and even the walls if required, right? So we can give planar views as well as the ceiling view and the floor view, and that is a low-hanging fruit. That is something we can do it quite quickly as well. Because again, for the drones, we have the maps. The same concept would apply for this one.
Right, exactly. It's another thing that I'm like, why hasn't anybody done this?
Wow, that's a super idea.
Yeah,
Because it's the same thing. You're just, instead of being 200 feet in the air or 400 feet in the air, you're 6 feet off the ground, right? So,
Exactly.
and there's inherent safety risks with flying drones on a site, and there's certain sites you can't fly drones at, but I can send somebody out there with a camera on their hard hat or on a monopod, and why can't I do the same thing I can do with the drone if they just walk a grid around the job site?
Something we'll immediately implement, Jason. This is the lowest hanging fruit for us, actually.
And then there's things like validation. So if we're getting essentially photogrammetry models down to 2 inch, half-inch accuracy, knowing when something is identified in the photograph, but it's in the wrong spot, right? And again, I'm not worried about that true like millimeter accuracy laser scan level, but hey, the duct was supposed to be here and it's actually 2 feet over this way. And now I'm going to have a problem because they didn't put in the right spot. And over here, there's supposed to be some pipes that are supposed to be over here. Avere has started doing some of that stuff, but of course they rely on true LiDAR scans.
Yeah.
And a lot of times don't need that level of accuracy, right? I just need that, couple inch accuracy to tell me, hey, something's generally in the right spot, or it's not even close, right?
Yeah. Serve as a guidance in a way, right? Not be super precise, but a high level guidance telling you maybe this is off. Why don't you look at it?
Yes,
And
exactly.
that was deviation analysis version 1, Q4 release, Jason. We have already got the alpha version out. Only with photogrammetry results doing deviation is our purpose, and we are trying to get it perfected out actually. So we're getting more and more data. We are looking, because the thing we want to be wary about is, say a pipe is a couple of inches off. It doesn't matter, right? If there's nothing creating a clash to it. You want to be tracking the impactful deviations, the ones that will actually create a further problem. So we are trying to analyze what is the best way to do that. Just showing deviations, we can do it quite quickly.
No, yeah, that's great. Or if something's missing, right? I also want to be able to mark. So if I say that I have a particular room, it's like office room, office, classroom, conference room, whatever, and I want to virtually inspect that room, right? And I want to say, they've said this particular trade, plumbing. We haven't closed in the walls yet, let's say, but they've done their in-wall rough in and their overhead rough in, and they're ready. We're going to close up the walls. We're going to hang the drywall and the sheetrock, and everything's going to be concealed. I want to make sure that everything that's supposed to be in the wall is actually in the wall. Now, I can do that with any reality capture system, right? But it requires manual processing, right? Somebody's got to look at the photograph and then compare the plans and say, hey, is this in the right, is all the stuff there? Another thing that I look for solutions such as yourself to do is, if I say, all right, this room's ready to be closed up, have that feature to be able to choose a space. These 4 rooms, 10 rooms, whatever, we're done with MEP. So, and then I want you to tell me, based on the photogrammetry model and the BIM or drawings that you have, that there's something missing. Something's either just totally not installed, or it's in the wrong spot, right? But we had a job where they forgot to put in transfer grills above ceiling. Nobody caught it, right, until the end of the job, and then they were just small little transfer grills, but they weren't put in, and they were clearly in the model, but they weren't in any of the photos. And somehow it got past a number of people, and we had to go back and add these transfer grills in. And so adding some level of automation with the photogrammetry and the model and the drawings and all that, of identifying, I'm ready to close up. Is everything there? Yes, no, it's in the wrong spot, it's totally missing, whatever the case may be. And then maybe at another stage when, okay, now we're ready to basically hand over the room. We're done built, we're completely done. All trades are done in this room, and basically run another check to say, okay, hey, here's the things that are missing.
That's great, actually. Some of the advice points are something that should be pulled up immediately in a product roadmap. And this is the kind of feedback that we are looking for, Jason. Not just telling, okay, the product is fine, maybe I'll use it. This is the feedback that truly matters.
Well, on this note, Jason, you have such a wealth of knowledge and understanding of not only this space, reality capture, and then the analytics, plus like what the roadmap should be for field teams to actually want to use it and what's actually useful. So I'm going to throw something out there. And we just have been kind of throwing around this idea the last couple of weeks of a product advisory group for folks like yourself that are really knowledgeable and have a vision of like, this is what our industry needs. And like, we get it. We're sure you're working with other companies and probably giving similar feedback. And, we're very agile right now, right? So we really want to get this right for the market, because again, we think there's a lot of problems that are unsolved for. And I very much get the piece that it takes a lot of resources to pilot on a first project, right? Of course, we want the opportunity to do that. We know the industry's been inundated the last few years, and now a lot of companies have the initiative of like, let's streamline our current tools and like reduce processes and workflows. But really where we come in is like, we can be that solution for consolidating tools, both from a reality capture and analytics perspective, right? With all the visual data sources. But, so I mentioned the whole like first project track. Obviously, we'd love to get on a project, but also the former piece, like getting your feedback. We're not asking for a big commitment, but just like, if you'd be open to another conversation like this with like NK and one of our other co-founders or product folks, like it would be amazing. And so anyway, what are your thoughts?
Yeah, I'd be interested. The more I can interact with the product, obviously, the more helpful I could be.
Right. We would find a way to just give you access, and like, so you could go walk around a site and like start to do some scans, and like absolutely, it needs to be in your hands for you to provide feedback. Totally.
Right. Yeah, that's something I'm interested in. I've done it many times with other solutions. So it's like I said, it's a little technical niche that I've found myself that I have a skill set in, I guess.
Yeah, no, I mean,
I like to
this-
figure out how to break things,
yeah,
make them do things that they weren't intended to do.
that's
And,
perfect.
and think of new use cases that we would probably have not thought of ever, right, Jason? That is super helpful.
Are you seeing my screen?
It says you've started screen sharing, but I don't, oh, there we go, yeah.
So this is an example. This is construction site, right?
Mhm.
So we've taken a laser scan into a BIM, and you can also see the line work on top of it. So I see what, it's just barely cut off on this here, but you can see the room number. I can see, the line work, and I can see the model, the 3D model, but I can also see the laser scan. These pipes weren't in the right spot, or these pipes weren't in the right spot, these vent lines. And then here's where that Procore integration comes in, right? This was an observation in Procore that these vents weren't at first the observation was that they were in the wrong spot, and then it was later noted that these are acceptable and they're going to be added to the as-built model, right?
Oh, nice.
Sorry, go ahead.
No, great. This is perfect. I was thinking that was a laser scan and the floor plan on top of each other. Is that so? I
Yes.
missed that. Oh, okay.
Yeah.
That's pretty cool.
So here's another, where we looked at, hey, here's where the steel embeds are supposed to be, but there's actually an embed here. And this embed is is also off.
Ah,
But you can see in here that not only is it the 3D model and the laser scan, but I also have the line work here. So I can see this is electrical room, DBC, whatever, and this is whatever room, and here's cleaning supply room, whatever. I can see, I'm not seeing everything in 3D. I'm only looking at the scopes, the certain things are turned off, right, in this case. But I am seeing still the 2D line work as well.
wow.
And this is just construction site, right? But I've made it do what I need it to do for this.
Oh, so those were image locations that you added these images in, right? Wow. Okay. So
Yeah.
instead of
So
taking
here's this is a concrete wall, right? And there was no sleeves in the wall, so we had to identify that, hey, there's supposed to be conduit coming through this wall, and they're going to have to core drill that, right? They didn't put the sleeves in the right place. And I think, no, not this location. Let me look at I know where it is. It's another location down here. So here you can see some core drilled hole, or I mean some sleeves here. And if you zoom in, you can see the sleeve locations here in the scan, right? But the location shown in the model is above that, is higher than that. And there's
okay.
holes in the wall here, but there's no pipes shown in the model going there. So these are all things that we identified, and then of course we originally noted these in here like this, and then we later came back and said, hey, let's make this a observation, right? And this is the Procore tie-in, right? So I can start whatever the observation is, and then that goes into Procore. But all this is a model on top of line drawings with a laser scan in the background.
Amazing.
Nice.
So we were able to look at, and in this case, we were specifically looking at all the penetration locations in the slab before they poured it. So I go to
Probably not many
this.
people will be using Struction Site like this. This is the first time I'm seeing it being used so creatively.
This is what it looked like, right?
Ah,
So then taking this data and saying, look, I have all these all these stub ups, right? I have embeds in the, up here in the concrete. Is all this stuff in the right place? And then by essentially slicing this into either a photogrammetry and putting it on the model, or taking the laser scan and putting it on the model in a 2D with the drawing, I can then see it like this. Maybe, come on.
And this is where you're coming from, right? The photogrammetric base, on top of it, the line drawings, and adjust the transparency of it. I can now see. This is great.
And is this all custom work that you all did, Jason, to get this as an output?
Yeah, I mean, this is where we've taken a product of reality capture solution like Struction Site, along with our Navisworks model and our laser scan, and we've put those things together to produce this, right?
Wow.
And then so the other thing is so what our teams want, let's see, go back to, I think we have it in here. I think this is the right spot. So this is kind of that idea of that photogrammetry, you know, image, although this is a model, right? But I would want to see the 360 capture on top of it.
Right.
But we've created these kind of area drawings with sleeve penetrations, right? So in this case, the team, they're wanting to know where all these sleeves are in this slab, right? So we can see all the pipes turning up, all the conduits turning up. I don't need to muddy it with all this extra 3D content. All I need to know is, are those in the wall? And I can use the 2D drawing to see that it's coming up in the right spot. I don't need the model here. I don't need the model of the walls, right? I can use the line work, and I can see the room that it is. I can see the column grids, and I can see the furniture layout. It's not 3D. It's simple. It's not cluttered. But the important thing that my superintendent needs to know when he's in the field and he's ready to pour this slab, is there a bunch of conduit sticking up right here? Are there 2 pipes sticking up right here? Is there a pipe in the middle of that wall? Is that there? Is that there? Are those there? And then if I can use the photogrammetry point cloud behind it to then further verify within reason that it's in the right spot, right? Then I really have something. So we've been using a combination of solutions to build this ourselves.
This is amazing.
And so let's see, I go to, I think they did it on the stem. So we've evolved our use of this to incorporate a lot of our BIM. So we now have, all of our sites have this 3D drawing, which is kind of like what you guys have, right? But I can go into it with, well, where are my images? They were there. There's one. You know, here's the overhead view of that area, and then there's usually 2 of them in here. He's only got one right now. There's usually one slightly tilted and one that's also, you know, orthogonal, right? But you see the value of having the line work on top of it, not just the model itself. Then I can see that, you know, what room this is and what column grid this is, and have some of these notations that you know, things that aren't necessarily going to show in the model. So
No, I completely hear what you're saying, Jason, and I can now visualize the benefit of this as well. How do we combine these 2 together?
because, and especially, again, for our superintendents, the critical point is for them, at least when we're initially building the structure, is where are the penetrations, slab penetrations, roof penetrations, wall penetrations, are they in the right spot? And traditionally, he would have to go to the plumbing shop drawing for that slab to find that. And then he'd have to go over to the mechanical shop drawing and go first find the right drawing and pull it up. And then the electrical, and you have to go through all the different trades, 10 different drawings to get an idea of what all sleeves he should have on the slab. And so by overlaying all this information together, we can say, there's 3 there, there's 4 over there, there's 1 over there. Okay, and he can just basically count and look generally on his iPad or his phone and say, are these in the do I have the right number, first of all, quantity of penetrations, and then second, are they roughly in the right spot? So then if I can rotate that, if I can look at that in plan view with some level of accuracy, but with a photogrammetry scan behind it, and say, yes, these are generally in the right spot, and or no, this one may be off. Let's manually check it, or check it by some other means and verify that it is off, or that it could be needs to be adjusted, right? Or maybe at that point, that's when we say, okay, we got to bring out the actual terrestrial LiDAR scanner and scan this thing and get a higher level of accuracy, right? But the magnitude of the work and the effort would scale up as the information tells us, or it would stop at that basic level of verification saying, yeah, we feel good, it's in the right spot, and we got the right number of penetrations there. And then again, when we're doing once we're doing the rough in, or having that validation with the drawing to say, to be able to visually see what's there, what's not there. And I'm working on pulling up. I don't have access to the data anymore, so I got to pull up some images. 1 second. There we go. Oh. Let me know when you see it.
Yeah.
So like this is just a 2D drawing, right? But I can clearly see in this color coding what's been done and what hasn't been done, and visually see what progress still has to be made and where they're working, that kind of thing. Of course, I got the quantities and things behind it, which you guys have, right? But just this level of graphic it's what they've been doing for many years, right? Albeit manually. So we should be able to easily recreate this, with the technology that you guys have. And then in object identification, I don't know how much, if you've ever seen or worked with like Numetrics, which is now Oracle, an Oracle product, and there's another field, AI, FYLD field. There's a safety platform like this, where it's detecting things like safety hazards. So this is not looking for beams and ceilings and floors and stairs. It's looking for things like ladders and equipment and full trash bins and things like that. And then identifying like, hey, you have like full trash bins on your job. Maybe you ought to clean up. Or the fact that there's a forklift on your project, there's certain safety hazards involved with a forklift. Or when I walked the job with the camera, we picked up 300 ladders on your job site. So you probably have an increased risk for a fall, right?
Got it.
Things like impalement hazards,
Yeah.
missing guardrails, open holes or exposed holes, things like that, using AI and machine learning, we can identify things like that. And again, it would be nice to have that all in one solution where it's saying, and it's not saying that this is like a violation necessarily. It's saying, hey, we've identified a potential hazard, or we're benchmarking that, you have an upward trend in the quantity of ladders on your job site. So therefore, you're more at risk for a ladder fall. So we can be proactive on our safety and say, this week we're going to have a toolbox talk or a safety training on ladder safety, right? And reduce safety risks or potential for safety risks by being proactive about things like that. So just outside the realm of what you're looking at now, but food for thought.
Amazing. So much food for thought. And I feel so badly. I have a hard stop. But NK can stay on a few more minutes and then he can come over after. And I'm just so excited that we connected with you because I think it's amazing how you're thinking about all this. And we definitely would love to have you part of our product advisory group and get it in your hands. So you two can just kind of wrap up with next steps. And yeah, Jason, it was awesome. Thanks so much for this conversation.
Yes, thank you, Meredith.
Thanks. So this was great, Jason. In fact, I was so intrigued in the way you were using the product. Maybe construction site folks would have also not thought, okay, these are ways it could be used actually. So that's really awesome. And would love to have you as a product advisory, as Meredith was saying, right? I think you can, because there's some things, right? For example, the safety detections and all of that. That's not something we can do 3 months later or 6 months later. Those are things we can do now. But we are trying to figure out what are the use cases we need to actually target and be more focused on. So, that will usually accelerate our product development journey. Example, you also mentioned the ortho maps, right? For the inside of the building, the ceiling maps, the floor maps. That is again something which we can do very, very quickly. We just didn't say how people will use it. And that industry knowledge, right, would super accelerate our journey, Jason.
Well, it's not, I think people would find it beneficial if they thought of it, right? Or if they knew it was available, right? But I guess that's just the creating creative workflows is kind of what I do and with the teams that I work with, and we find innovative ways to use the solutions we have. And
Jason, we have one technical issue, though. Meredith just pinged me, and this is the same meeting we have in the same Zoom ID. So unfortunately, we'll have to end this. But what will be the best way to stay in touch, Jason, and then have the regular follow-ups on the product advisory?
Meredith has my email, so she can reach me.
Perfect. We'll do that, Jason. Thank you so much for your time. We went half an hour beyond, and I would love to continue this conversation. Unfortunately, we have to actually start that.
All right. Nope. I appreciate it.
Thank you, Jason. Have a
Thank
great
you.
day. Bye.
Bye.